And we are live. I'm Joe.
Hey, everyone. Good morning, good afternoon, good evening, whatever time zone you're in right now. Welcome back to Sip and Talk. I'm Sunny. And before we jump in, I have to confess something. I woke up this morning feeling completely, utterly drained.
Oh, rough morning.
I mean, literally feeling like a 3-year-old smartphone that just will not hold a charge anymore. So to even feel alive today, I went out and bought a massive venti caramel macchiato and a chocolate donut. Oh my God, that first hit of sugar, I felt like I was finally a functioning human again.
Wait, stop right there.
What?
You realize what you just did to yourself, right? You weren't recharging your battery at all. From a biological standpoint, you basically just poured cheap, low-grade, dirty oil straight into your cellular engine.
Come on, it was just a donut.
Based on the research we are unpacking in today's Sip and Talk, your mitochondria are probably screaming for help right now.
Wait, mitochondria? You mean like those little bean-shaped things from middle school biology? Don't those just, run on autopilot as long as we're alive?
Actually, it is not that simple at all. We are diving into the groundbreaking findings of Professor Thomas Seyfried today, and he points out that mitochondria are not just these isolated power plants. They're basically the brains of the cell that determine your destiny. And we really need to pay attention because he brings up a staggering statistic. Right now, in our country, 1,700 Americans die from cancer every single day.
Jeez.
Yeah, that is roughly 70 people every single hour losing their lives to this disease.
Wait, 70 people an hour? That number is absolutely terrifying. But, aren't we always told by our medical system that cancer is mostly a genetic lottery? Like, it's just random genetic mutations.
And that is exactly where we want our Sip and Talkers to practice some independent critical thinking today. Professor Seyfried presents a totally paradigm-shifting view. He argues that cancer is not fundamentally a genetic disease. It is actually a metabolic disease, and the root cause is damaged mitochondria.
A metabolic disease.
Right. He uses this incredible analogy. Look at wolves in the wild. They run around, they eat natural, unprocessed foods, and they almost never get cancer. But then, look at our domestic dogs.
Oh, I see where this is going.
Right. We keep them in temperature-controlled apartments. We feed them highly processed kibble. They don't move much, and today, cancer is the #1 killer of the domestic dog.
Wow, that hits so close to home. And honestly, it's impossible not to connect that to the systemic issues we see in our broader society right now. When we look at Washington, you see politicians like Trump heavily emphasizing healthcare reform and public health policies.
Absolutely.
If the root cause of this epidemic is our modern American lifestyle, like our highly processed carbs, the chronic inactivity, the high stress, terrible sleep, then this is a massive systemic societal issue. It's not just an isolated medical problem for a doctor to fix.
Exactly. And so our mission for today's Sip and Talk is to objectively unpack this bioenergetic roadmap. We are going to explore exactly why cancer cells become so greedy for sugar and glutamine, and what the science says about protecting your own cellular engines.
Sounds like a heavy topic, but a really hopeful one. So everyone, grab your coffee, preferably without the sugar, or your green tea, because we are getting right into it.
Oh, but real quick, before we get into the heady science, we do have to give our mandatory disclaimer. We are not medical professionals, and we aren't investment experts.
Yeah.
The information we're talking about today is for objective data reference only. You absolutely must consult a professional doctor before you implement any dietary or lifestyle changes.
Right, safety first. So let's unpack this engine room. We know our modern lifestyle is supposedly damaging our cells, but how exactly does a broken cellular engine turn into a cancer cell?
Well, first we have to completely unlearn what we were taught in middle school.
Goodbye, little jelly beans.
Yeah, exactly. Under an electron microscope, the reality is that mitochondria are this dynamic, highly interconnected tubular network spreading all throughout the cell. They don't just make energy, they regulate everything. They even tell the cell when it's time to divide, and more importantly, when to undergo apoptosis.
Apoptosis, that's programmed cell death, right?
Spot on. If a cell becomes too damaged, a healthy mitochondrion pulls the plug to protect the rest of the body. They are the brakes of the car.
Okay, so if they are that smart, what is actually breaking them? What causes the damage in the first place?
The culprits are things we interact with every single day. Seyfried's data points to chronic inflammation as a huge driver. Then you have intermittent hypoxia, which is basically sleep apnea, where millions of Americans are literally suffocating their cells for 30 seconds at a time while they sleep.
Oh, wow. I never thought about sleep apnea like that.
And then there's the environmental carcinogens. We're talking about microplastics, forever chemicals like PFAS, synthetic pesticides like glyphosate penetrating our food supply, and heavy metals in our municipal water systems. Over time, these environmental stressors chronically attack the delicate inner membranes of the mitochondria.
Okay, but this is where I get a little confused. If the mitochondria are so damaged that the cell can't produce energy efficiently anymore, why doesn't the cell just die? Like, why does it turn into cancer instead of just shutting off?
That is the million-dollar question, and the biology here is fascinating. It actually traces back to Otto Warburg's discoveries in the 1920s. When the modern, efficient oxygen-burning power plant inside the cell is damaged, the cell is suffocating. But life has this desperate drive to survive.
Right.
In a total panic to avoid dying, the cell falls back on an ancient, prehistoric evolutionary pathway to generate energy. It reverts to fermentation.
Ah, okay. So it's basically like our modern American smart grid failing, and instead of just letting the lights go out and freezing, the cell goes down into the basement and just starts burning dirty, raw coal just to keep the heat on.
That is a brilliant analogy.
Yeah?
Yes, it starts burning dirty coal. And this explains everything about cancer behavior. Because the mitochondria are broken, those breaks we talked about, the apoptosis signals, are completely gone.
So there's no off switch anymore.
Exactly. The cell goes rogue. It becomes this selfish, prehistoric, raging beast where its only goal is to multiply out of control, and it completely ignores all signals from the rest of the body.
But wait, if it's relying on fermentation burning dirty coal, that has to be incredibly inefficient, right? How does a cell even survive on that unless it drastically increases its fuel intake?
You hit the nail on the head. Normal mitochondrial respiration produces a ton of energy from one molecule of glucose. Fermentation produces almost nothing. So to survive, the rogue cancer cell needs massive, unprecedented amounts of fuel.
Which is why we always hear about tumors aggressively hoarding resources.
Precisely. And that fuel comes in two forms: glucose, which is sugar, and glutamine, which is a highly abundant amino acid in our bloodstream.
Okay, so if we have this rogue cell aggressively demanding sugar and glutamine just to keep its dirty coal engine running, how do we know if we are at risk? Is there a way to measure this?
Yes. Seyfried brings up a very specific tool for this called the GKI, or the glucose ketone index.
GKI, got it.
It's a ratio that compares your blood sugar levels to your blood ketone levels. If we look back at our Paleolithic ancestors, they naturally lived in this zone of prevention, meaning they had a very low GKI.
Because they obviously didn't have 24/7 access to, drive thrusts and processed pastries.
Right, and they exercised relentlessly just to survive. Their bodies were incredibly efficient at burning fat.
I want to dig into that fat burning aspect for a second, because this is where I think the mechanism gets really interesting for treatment. Normal, healthy cells have metabolic flexibility, right?
Yes, exactly.
Which means they can seamlessly transition from burning glucose to burning ketones, which are produced when our liver breaks down fat. Our healthy cells actually thrive on ketones. It's a very clean-burning fuel. But cancer cells...
I can't do it.
Because their mitochondria are structurally broken, right? They literally lack the biological machinery to burn fat.
You got it. If you remove their glucose supply and flood the system with ketones, the cancer cells essentially choke.
Wait, so if you go on a strict therapeutic ketogenic diet or do supervised fasting, you are basically starving the tumor of glucose while your healthy cells are just thriving on ketones.
Exactly.
It's like you're putting up this invisible metabolic shield around your healthy cells while completely cutting the supply lines to the rogue ones.
That is exactly what is happening. Now, to be fair, Seyfried emphasizes that this doesn't eliminate the cancer entirely on its own.
Because of the glutamine, right.
Right. The tumor still has access to that second fuel. But pushing the body into deep ketosis manages the cancer. It drastically lowers systemic inflammation and pushes the tumor into a weakened, non-aggressive state.
Okay, but this brings up a huge question for me. If starving the tumor of sugar works so incredibly well, why isn't this the standard protocol everywhere? Why is Washington, our FDA, and the mainstream medical establishment seemingly ignoring this?
It's not that they're malicious. It really comes down to a fundamental theoretical divide. Standard oncology is hyper-focused on the somatic mutation theory. All their education, their multi-billion-dollar tools, they're all designed to target DNA mutations in the nucleus.
Right, the genetic lottery idea.
But Seyfried argues that those genetic mutations are actually the downstream effects of the initial mitochondrial damage. The mutations are the smoke, not the fire. We're spending billions trying to clear the smoke while ignoring the blazing fire in the engine room.
Wow. And this leads to what I think is the most heartbreaking paradox in our entire healthcare system.
Yep.
When you look at the standard hospital nutrition provided to cancer patients today, Dietitians frequently give them these meal replacement shakes.
Oh, I know where you're going with this.
And if you read the ingredients on the back of those shakes, they are packed with high fructose corn syrup, maltodextrin, just pure refined sugars. And their medical rationale is to prevent cachexia, right? The severe weight loss and muscle wasting. They just want the patient to keep their calories up so they can survive the chemo.
It is absolutely tragic because from a metabolic perspective, feeding them high fructose corn syrup is literally throwing gasoline on the fire.
Yeah.
Cachexia isn't just normal weight loss.
Yeah.
It is pathological.
Yeah.
The tumor literally acts like a parasite. It secretes inflammatory cytokines that actively dissolve the patient's skeletal muscle tissue.
Just to get to the glutamine.
Exactly. It harvests the amino acids from the muscle to build new DNA. So by giving a patient those sugary shakes, you are flooding their bloodstream with glucose.
Yeah.
You're handing the rogue cells exactly the two things they need, glucose from the shake and glutamine from the dissolving muscle.
You're feeding the beast while it's fighting the chemotherapy, whereas ketogenic weight loss, as the data points out, is totally different. It's therapeutic, fat-burning weight loss that actually protects your muscle tissue.
Precisely. And this raises a crucial point, because people might hear this and think Seyfried is entirely anti-chemotherapy.
Right, like he's suggesting we just reject modern medicine and only eat avocados or something.
Exactly, which would be a very dangerous stance. But he is not saying that at all. His approach is all about synergy. He advocates for what he calls a press pulse therapy.
Press pulse. Okay, break that down for us.
The press is the chronic metabolic stress you put on the tumor through nutritional ketosis. You drop the patient's GKI. The healthy cells go into bunker mode. They transition to ketones and build up robust defenses. But the cancer cells can't. They're starving and incredibly vulnerable.
And then comes the pulse.
Yes. Once the tumor's shields are completely down, you pulse it with much lower, highly targeted doses of standard chemotherapy, along with repurposed drugs like mebendazole that specifically target the glutamine pathways.
So because the tumor is already metabolically weakened, you can destroy it without having to use those massive toxic chemo doses that cause horrific side effects.
Exactly. You protect the healthy tissue while devastating the rogue cells.
That is just a brilliant synthesis of metabolic therapy and targeted pharmacology. Let's play a fun hypothetical game for a second.
Okay, I'm good.
If Professor Seyfried were suddenly put in charge of our country's public health policy, if he had the pen in Washington, how would he stop those 1,700 daily deaths? What is his blueprint for us?
His blueprint is heavily focused on prevention and environmental root causes. First, massive public education. People need to understand this bioenergetic map. Second, he wants to eradicate food deserts.
Oh, that's huge.
It is a tragedy that millions of Americans only have access to ultra-processed, cheap, inflammatory food. He wants to make healthy, single-ingredient foods affordable for everyone. Third, banning forever chemicals, cleaning up the water supply, and getting synthetic pesticides out of agriculture.
And I imagine a massive push for exercise, too, since muscle acts as a sink for glucose. But you know what I found really interesting in his blueprint?
What's that?
Despite the urgency of all this, he specifically says there should be absolutely no government mandates on diets.
Right.
Like no one from Washington should be kicking down your door to take away your donuts or mandate a keto diet.
Yeah, he is very clear on that. It is all about objective patient empowerment. He advocates for giving citizens the knowledge and the tools like continuous glucose monitors to see in real time how their daily choices affect their bodies. You give people the data, and you let them make the call for themselves.
That is such an empowering perspective. Now, before we wrap up, there is one final mind-bending concept from this data that we haven't touched on yet, and it fundamentally changes how we view metastasis.
Oh, man, this card is wild.
Right. When cancer spreads from a localized tumor to the liver or the brain, that is when things get truly dire. What does this metabolic theory say about how cancer actually spreads?
Okay, so Seyfried's data proposes a mechanism that sounds like pure science fiction, but the biological evidence is compelling. He proposes that spreading cancer cells are not just random tumor cells floating away, they're actually macrophage tumor hybrids.
Wait, macrophages, as in the white blood cells from our own immune system, the ones supposed to protect us.
Yes, our own immune cells. Normally, macrophages are the cleanup crew. When a tumor forms, the immune system detects the inflammation and sees the tumor as an unhealed wound. So it sends in legions of macrophages to fix it.
Okay, that makes sense.
But because the tumor microenvironment is so chaotic, acidic, and damaged from all that fermentation, the normal biological processes just break down.
And instead of destroying the tumor, they end up fusing with it.
Exactly. The macrophages abnormally fuse with the tumor cells. They create a rogue hybrid. Now think about what a macrophage is naturally programmed to do in our bodies.
Oh, wow. It's designed to enter the bloodstream and travel through the body.
Bingo. By fusing with it, the tumor has essentially hijacked a specialized all-terrain vehicle. This rogue hybrid cell now has the machinery to move anywhere it wants. And the craziest part, this travel is almost entirely driven by the consumption of glutamine.
That completely upends everything we think we know about cancer spreading. It's not just a piece of the tumor breaking off, it's our own compromised immune cells being hijacked as the getaway vehicle.
Yeah, fueled by an amino acid we produce naturally. It shifts the entire narrative from a random genetic accident to a complex environmental and metabolic crisis.
It is an incredibly intense, but ultimately, I think, very empowering perspective to ponder. And as always, we want to remind our Sip and Talkers that our goal here is to present alternative scientific perspectives and encourage you to think critically. We are not criticizing or discriminating against any nation, medical institution, or group of people. We're just exploring objective biological facts.
Exactly. The knowledge is out there, and the power really is in your hands. Your daily choices, your environment, and what you put on your plate matter immensely to those trillions of little engines inside you.
Absolutely. So on that note, I'm going to very carefully step away from the rest of my caramel macchiato and go find some green tea.
Good call.
If you enjoyed this conversation, please subscribe to Sip and Talk so you never miss our analysis of the research shaping our world. And a huge, energetic shout out to our old friend Mickey. Make sure you head over to his YouTube channel, Mickey to Life, to check out his latest amazing travel vlogs. He puts so much incredible work into them.
He really does. So what does this all mean for you tomorrow morning? The next time you wake up feeling completely drained and reach for that quick sugar fix, ask yourself, are you actually giving your healthy engines the fuel they need to thrive, or are you just pouring cheap, dirty coal into a broken engine? Think about it. We'll see you next time.